in which we do the type check. Okay, we check whether the correct type is there or not. So type checking, we perform the type checking in basically in the semantic analysis phase. Okay, in the third phase of the compiler, we use the semantic analysis. Okay, I mean this is the third phase, and in that phase only we do the type check and parsing. So parsing happens in which phase? Parsing happens in syntax analysis. Okay, the work of the syntax analysis. Hello everyone, can you please confirm whether my audio and video is visible and audible or not? Can you please put a comment in the comment section so that I understand I am clearly audible or not? Okay, please put a comment. Okay, okay, so it looks good. So thank you everyone for joining in. So today in the course of compiler design from GeeksforGeeks Gate, we will be solving the previous year questions of Gate in the parsing and syntax directly translation. Okay, so we had the same topic and we talked about the same topic in yesterday's session, but the number of questions from this topic is actually much greater than the other topics of the same subject. Okay, so in this topic basically, in this topic we'll put most of our time in solving the previous year question. Okay, so firstly the first question you can see that question was arrived in GATE 2018. So it is saying that which statement is false. Okay, in the given these four statements, which is the false one. So first statement, let's see. So it says that context-free grammar can be used to specify both lexical as well as syntax rule. Okay, it's true that in lexical and syntax rule we use the context-free grammar. Okay, in lexical and syntax rule we use the context-free grammar. If you remember, the in the syntax rule itself that was made of the context-free grammar, and the lexical analysis there we use the regular expression. Okay, we use the regular expression or regular grammar. So regular grammar is nothing but a part of the context free grammar. Okay, so you can say that the context free grammar was also used in the lexical analysis as well as syntax rule. So the first question, I mean the first statement is true. Okay, now checking the second statement, it is saying what? The type checking is done before parsing. Okay, so type checking is a phase in which we do the type check. Okay, we check whether the correct type is there or not. So type checking, we perform the type checking in basically in the semantic analysis phase. Okay, in the third phase of the compiler we use the semantic analysis. Okay, I mean this is the third phase, and in that phase only we do the type check and parsing. So parsing happens in which phase? Parsing happens in syntax analysis. Okay, the work of the syntax analysis is to do the parsing. Okay, and here the syntax analysis phase happens before semantic analysis. Okay, if you see the structure or flow chart, then the lexical analysis, okay, I mean the first part is the lexical analysis, then that is the syntax analysis. Okay, the third phase is semantic analysis. Okay, so it means we can see that the parsing is happening before type checking. Okay, so the option 2, that is the type checking is happening before parsing, it is the false option. Okay, it is not correct because the parsing is happening before type checking, as because the parsing happens in the syntax analysis phase, right? Now what is the third option? It says the high level language programs can be translated to different intermediate representations. That is true. High level language means our C, C++, Java, all the languages you can think of, all the computer language. So those can be transferred to different intermediate representation. There is no issue. Okay, so that is true. And the arguments to a function can be passed using the program stack. Okay, our argument to a function can be passed using the program stack. That is also true, because I mean all the arguments, all the variables or values that are passed in certain function, so they use the program stack. It's true that in program all the functions are passed through some stack, right? So the fourth option is also true. So only the false option is what? That is the second option. So this is our correct, option, okay, which is false. So in this way, I hope that you understood all of these four options, and the second is the false option. Okay. So going forward, this this was arrived in GATE 2016. Is a question of set 2. So it says that which of the following grammar is free from left recursive. Okay, what is left recursive? Left recursive typically looks like this. Okay, it typically looks like this, means the variable that is in the right side, that should, the same variable should be there on the, I mean the variable that is in the left side, okay, of the production rule, the same variable should be there in the right side of the production rule, and for each part it will be in the left position. Okay, I mean firstly the variable, then some terminal. Okay, firstly the non-terminal, then some terminal. So if this type of, okay, if this type of production rule is somewhere in the grammar, then we can say that the grammar is having left recursion. Okay, if the grammar is not having this type of production, so we can say that the grammar is free from left production. Okay, now if we check all of these options starting from the option A, so we can see that in option A, the second production rule, that is A tends to, I mean capital A tends to capital A small a. Okay, here we can find something as left recursion. Okay, here the left recursion is there because it is following the same pattern, right? So the option A is not correct option. Okay, because it is not free from left recursion. Now what is there in the option B? So let's check the B. Okay, before B, let's check the option C itself. Okay, so in option C, you cannot find directly any left recursion. Okay, there is not any directly left recursion, but there is some indirect connection. So what is the connection? Let's talk about that. So S tends to AA. It is one production rule is there. You can see. Okay, this is the production rule. Now this A itself, can generate the SC. Okay, it can generate the SC. So overall the A can generate SC. Okay, if the A is generating this SC, then overall the upgraded production rule, if you say that what is the modified production rule, this situation may occur. Okay, so in specifically in this situation you can find the left recursion. Okay, in this situation you can find the left recursion. So option C is not also the correct option. Okay, it is not free from left recursion because it is having the indirect left recursion. Okay, in the option A it has the direct, I mean you can just directly see the grammar and you can tell that yes, it is having the left recursion, but in the option C we don't have the direct left recursion. Okay, there you can find some indirect relation is there. Okay, now going forward to the option D, so here you can see that A and B. Okay, option D is doing what? If you see A, so A is generating capital B small d. Okay, and the capital B itself, this capital B itself is generating what? It is generating capital A and small e. Okay, capital A and small e and d. So overall you can see that left recursion is also there. Okay, this is, if you talk about the modified version, so you can see the left recursion is also there. So obviously option D is not the correct option in this case also. So what is the correct answer? Correct answer is B. Okay, why? Because you cannot find any left recursion. Okay, it is very, I mean to the point. Okay, if you go with the S, so S to AB, okay, it is hardly, if you want to reduce, then A can be reduced to BD, and BD itself, this B itself will be reduced to E, or the A can be reduced to null. Okay, if the A is reduced to null, then the only B will be the option. Okay, as well as this BB. So B can be reduced to E. Okay, let me explain. Okay, let me explain. So see, this A, I mean, if you try to write all the terminal, then what it will come? First of all, A gives, I mean, S gives AB, then BB, then C. Okay, so C is here perfect because there is no issue with the C. So only we can change that these two variables. Okay, that is the capital AB and capital BB. So if we remove the capital B, then what will come? In place of capital B, we can place the small e. Okay, because we can see this production rule. This production rule is what it is reduced. I mean, the capital B is changing to small e. Okay, so in this way we can change this one also, and the first, I mean the first production rule, that is capital A small b. So you can change itself. I mean in place of this capital A you can put BD. So BDB will be one option, and you can place also null. If you place null, then B will be the only thing that is left. And from this part EB and C will be coming. Okay, EB and C will be there. There won't be any change. Only in place of this A. Okay, only in place of this A we can put BD as well as B. Okay, so this BD, this capital B will can be again converted to E. So EDB, then B, then EB and C. So finally, from the starting symbol we can get this four type of terminals. Okay, so ultimately these four type of production rules can be there. So overall, if the grammar will be an left recursion, okay, so if in the grammar there is any kind of recursion, whether that is left or right, so the grammar should be infinite, right? But in our this case, our in the option B, in option B itself we are getting the finite grammar. Okay, there are finite number of production rules, so those are coming. So it means that there is no point of discussion with the recursion. Okay, because there won't be any recursion right or left. So B will be our correct answer. Okay, B is our correct answer for the given question that was arrived in GATE 2016 set 2. If you have any question or any queries, please put it in the comment section so that we can get back to you with your doubt. Okay, please show your query for the better understanding of our course. Okay, now what is next? The next question is, it was the GATE 2015 question of set 1. So question is saying what? It is saying that which one of the following is true at any valid state in the shift reduce parsing. Okay, which one is the true? So it says that viable prefixes appear only at the bottom of the stack and not inside. Then the option 2 is what? Viable prefixes appear only at the top of the stack, not inside. Then the third option is the stack contains only a set of viable prefixes and stack never contains viable prefixes. Okay, so before going forward, first we need to understand that what is this viable prefixes. Okay, so viable prefixes is what? So viable prefixes is what? If you talk about the definition is that the prefixes of right sentential forms that can appear on the stack of a shift reduce parser. Please note it down. Okay, parser are called viable prefixes. Okay, so overall, what does it mean? It means that the prefixes of right sentential form, okay, that can appear on the stack of a shift reduced parser are called the viable prefixes. Okay, so the definition itself is telling that the right sentential form, okay, the prefixes of right sentential form that are appearing on the stack. Okay, so it should be, the correct option should be the third option, that is saying what, the stack contains only a set of viable prefixes. Okay, because in the definition you cannot find anything about the bottom of the stack or top of the stack. Okay, so it should contain the viable prefixes, that and that too only a certain set of viable prefixes. Okay, so there won't be something like the bottom of the stack or something like the top of the stack. So just noting down, for this question it will be the stack contains only a set of viable prefixes, and this is the definition of a viable prefix. Okay, so going forward to the next question, it is just a matching with which part is doing actually which operation. So first of all, the lexical analysis. So lexical analysis is something where we are using the lexical analysis using some regular expression or something. It means it is like quite associated with the regular grammar itself. Okay, so it means that here the correct option should be the option 2. Okay, option 2 should be the correct option for the lexical analysis. So it is option 2. And parsing, what the parsing is doing, parsing is just making the production tree or the parse tree, right? So that should be the option 4. Okay, parsing is doing what, that is using the, that is making, actually generating the production tree or parse tree. Then the for option D itself, expression evaluation. So expression evaluation, we do the expression evaluation using the post order traversal. So if you have seen the semantic analysis, in that place we do, we can perform the expression evaluation using the post order traversal of the tree, right? So this is one option. And the lastly, register allocation, the only option that is left, that is the graph coloring. Okay, register allocation means we can allocate the registers using the graph coloring method. Okay, so what should be the correct answer, option for this? That should be the 2413, right? So 2413 is the option C. So option C, 2413, that would be the correct answer for the given question. I hope that you are understanding. If you have any question, please put it in the comment section so that we can get back to you with your doubt. Okay, so going forward, this is the 2015 set 3 question itself. Okay, at that time, and in the 2015, there is 3 sets. Okay, it means you can assume the number of applicants, how much, I mean how many students appeared for the GATE computer science in 2015. So that's fine. So the question is saying that among simple LR, okay, simple LR means the SLR, canonical LR, okay, or CLR, and look ahead LR, that means the LALR. So we have the options for SLR, CLR, as well as the LALR. Okay, which of the following pairs identify the method that is very easy to implement and the method that is the most powerful? So in this 3, among these 3, that is the very easy is this one, the SLR parser. Okay, why it is very easy? Because the parse table is small, because the parse table for this SLR1, okay, this is very small, as well as the simple parser generation algo is there. Okay, simple parser generation algo is there, and that is also, for these two reasons, the SLR1 is the simple, the very easy method to implement. Okay, so our first option should be SLR. Okay, and it is saying the method that is the most powerful. Okay, we know that the CLR1 is the most powerful method. Okay, CLR is the most powerful because the LALR is what? The LALR, okay, the last LALR, it is not the most powerful, it is just the generalized version of the CLR1 or the CLR1 parser. Okay, so you can say that the LALR1 is not the most powerful algorithm, but it is the most useful algorithm, because in most of the like scenarios, okay, most of the compilers, if you find that internally they are basically using the LALR1 parser. So anyway, because that is the like most efficient, you can say the LALR1 is the most efficient parser, but anyway CLR parser is the most powerful. Okay, though it is difficult to implement, but it is the most powerful. So our option will come that the very easy to implement is the SLR1, and the method that is the most powerful, that is the CLR1. Okay, CLR1 parser as well as the SLR1. So what should be the correct option? First is not the correct option, second canonical, no, it is not the correct, last one, first LALR is not the correct, so the third one, option C, is the correct option, because here the SLR1 is at the first place and canonical LR means the CLR, this is in the second place. Okay, so this is the correct option, option C. Fine. Now going forward, this question was arrived in GATE 2015 set 3. So it is saying that the grammar is given in which the S, F and H, these are the non-terminal symbol, and PDC, these are the terminal symbol. Which of the following statement is are correct? So the statement 1 is what? LL1 can parse all the strings and LR1 can parse all the strings. So we should verify using the LL1 method and LR1 method. Okay. So first of all, you need to see that both of this LL1 and LR1, okay, both of these parser should be unambiguous. Okay, I mean both of this LL1 parser as well as LR1 parser, they will work on only the unambiguous grammars. Okay, but our given grammar, this is not unambiguous. Okay, because this is ambiguous grammar. How? Let's say you need to generate the string C. Okay, your target string is C. So there are two ways to generate C. How? First of all, starting with the starting symbol S, and firstly we are generating F, and from F we can generate the terminal C. And to generate the terminal C, we have another option, that is from S we can generate capital H, and from H itself we can generate small c, or you can say the terminal C. So there we are getting two options or two parse tree for generating the string C. Okay, for generating the string C we can have two parse trees. So that should not be a case of unambiguous grammar. Okay, so it is what? So the given grammar is not unambiguous, it is what? It is ambiguous. Okay, the given grammar is what? It is ambiguous, and an ambiguous grammar cannot be LL1 or LR1. Okay, ambiguous grammar, let me write it for your sake of understanding, that ambiguous grammars cannot be LL1 or LR1 grammars. Okay, so it means that LL1 or LR1 parsers cannot parse the ambiguous grammars. Okay, so the option D, or the last option, that should be the correct one, because neither S1 nor S2 are the correct. Okay, both of them are wrong because the given grammar is neither LL1 nor LR1. Okay, I hope that you are understanding. If you have any question, please put in the comment section. Right. Now going forward, this questions was arrived in GATE 2016 set 1. Okay, so it is saying that the syntax directed translation scheme is there with the non-terminal S and A and terminal A and B. Okay, so the output printed by the bottom-up parser of the input AAB. So our starting will be AAB, right? Our starting is what? It is AAB, and we should ultimately not from this. We should ultimately generate the starting symbol S. Okay. So first thing we can do that from the given A, okay, from the given A, we can generate the S. Okay, I mean we can reduce it. We can reduce it. So if we give the numbers of the production rule 1, 2 and 3 I am using. So here we are using actually the production rule 2. Okay, and after that this SB can be reduced to A. Okay, this can be reduced to capital A, and what is the production rule we are using? That is the production rule 3. Okay, production rule 3. And finally this small a capital A, that can be reduced to our starting symbol S, and what is the production rule for the reduction? That is the 1. So in bottom up parser we can see that we are using the production rules 2 after 3. I mean after 2 we are using 3, then we are using 1. So we are using production rule 2, 3, 1. So the semantic rule or the semantic action that is associated with the production rule 2, the semantic action that is associated with the production rule 2 is to print 2. Okay, so from the production rule 2, say this is the production rule R and this is the semantic action. Okay, so here in the second production rule we need to print 2, in the third production rule we need to print 3, and in the first production rule we need to print 1. So 2, 3, 1 will be the correct option. Okay, so 2, 3, 1 will be the correct option for the input small a and small b. Okay, this is a type of syntax directed translation questions. So these are very common question which you can get in the actual exam itself. And I mean obviously this is the a question of the original GATE question. Okay, so you can get this type of questions, and these are very much easier. Okay, if you have any question please let us know. And this is one GATE 2019 question. It is saying that which of the following kinds of derivation is used by LR parser. So LR parser is basically, LR parser is a type of bottom up parser. Okay, LR parser is a type of bottom up parser, and for the bottom up parser the rule we follow, that is the rightmost derivation in reverse. Okay, rightmost derivation in reverse. So that is the main thing. So if you don't know that what is the rightmost derivation, so let me explain with an example. So let's take an grammar G. Okay, let's take an grammar G. So the grammar can be like starting symbol S. So it is generating 3 non-terminals, that is the A, B and D. So A is generating small a, B is generating small b, and D is generating small d. Okay, so these are the 3 terminals. Now let's take an example. Okay, so we are generating the string ABD itself from the given grammar. So what are the reduction steps we can follow? That is the ABD. Okay, and we need to follow the rightmost derivation. It means firstly that D, the rightmost variable, will be converted to the terminal. Okay, so we are using the, if you give the number of 1, 2, 3, 4, if you give the 4 production rule numbers, so firstly we are using the 4th production rule, and after that we are reducing the capital B. Okay, that is the rightmost for now. So now we are using the production rule 3, and lastly we can use the production rule 2, and that will give us our target string. Okay, it is generating our target string. So ABD will be our target string. So what we are doing, we are just taking the rightmost variable, and we are generating the corresponding terminal, okay, of that. So in this way the rightmost is clear, I think. Okay, so in this way we do the rightmost derivation, and in reverse, so I used it is the top down parser I am using, because we are starting from the starting symbol and we are generating the string. Now for the bottom up parser we need to start from the string itself. Okay, from the for the bottom up parser we need to start from the string itself, and we can eventually slowly generate the starting symbol. Okay, so in that case we need to follow the reverse order. Reverse order means we are starting from the string and we are going back to the starting symbol. So overall if you say it should something look like this: ABD, then this A will be converted to capital A, then BD, then the B will be converted to capital B, D, and lastly the D will be converted to ABD, and finally S. Okay, so it means that we are following the rightmost derivation in reverse order. Okay, so that is the rule, okay, to be followed for the bottom up parser, and as LR parser are one kind of bottom up parser, so we can use this derivation type. So the next question is saying what? It is saying that compute the follow set of non-terminal B. Okay, it means that we need to compute the follow of B and write the index values for the symbol of follow in the set of descending order. So what does it basically mean? First of all, follow of B. So in the follow of B we can see that follow of B will be first of D. Okay, so first of all follow of B will be first of D. Follow of B will be first of D. So in first of D we can get the symbol D, and we can get the symbol null. Okay, if we get the symbol null, then we need to add the follow of D also. Okay, how, if we get the null, then what will be after this capital B? If the D is converting to null, then after the capital B there will be the follow of capital D also. Okay, so union to follow of capital D. So in follow of capital D we can see that in follow of capital D, that is actually small a. Okay, so in follow of capital D it is generating small a, and first of capital D it is giving a small d. Okay, so using both of them, these two will be our set. Okay, these two elements will be there in the set of follow of B. Okay, so in the follow of B we can get D as well as A. So what is the index value of D? We can see the index value of D is 1. So index value of D is 1, and index value of A is what? The index value of A is 3. So we need to write the follow set. We need to write the index values in descending order. Okay, we need to write the index values in descending order. So this is, you can see it is in the ascending order. What will be the descending order? That is the 3, 1. Okay, 3 and 1 will be our answer. So this is a reference answer is given. If the follow is ABD dollar, then the answer should be 3210. So in this case our answer will be 31. Okay, because we are following the descending order itself. So our answer should be something like 31. Okay, this question was arrived in GATE 2019. That time GATE was conducted by IIT Madras. Okay, IIT Madras. So that's good. Going forward to the next question, that is what? This question was arrived in also in GATE 2019. It is based on the parsing. Till now, if you have faced any issue in any of those previous questions, please let us know so we can get back to you. Okay, please understand that the previous year questions are the very important question for the GATE exam itself. Okay, because after knowing the concept, the first thing that will appear that you need to put the knowledge. Okay, you need to use your knowledge, whatever you have gained from the course content itself, and that the most useful way I would suggest that solve the previous year questions. Okay, if you can solve almost the 70% previous year question, that means uh, you are like more than eligible to join any IIT or go for some good PSUs. Okay, so if you can solve the 70% previous year questions by yourself after showing, after seeing the content itself, that means that you are good to go. Okay, so that that's the thing I was telling. And after that you can also attempt the our mock test itself. Okay, if you attempt our mock test, then you will also be familiar with the exam pressure or exam time feeling. Okay, what feeling you will get in the actual exam, you will get the same feeling in our Geeks for Geeks mock test also. Okay, you need to appear for all the mock tests, whatever you can do. So that is like the basic way to prepare for GATE exam. Okay, fine. So I don't see any much comment. Okay, so it seems like you are understanding. If you have any doubts or any queries, even after the live session, please put it in the comment section so that we can get back to you. Okay. So anyway, so it is saying that consider the augmented grammar given below. This is the grammar, and we need to see the number of items in the set of Goto of I0 and the less than sign. Okay. So what is I0? First of all, I0. So let's write the I0 itself. So that should be started with the augmented grammar. Okay, augmented grammar, and the point or dot is before the variable s. So all the productions are with the starting from the variable s, we need to write them. Okay, there were only two production rules. So that's fine. So these two dots are before some terminal. Okay, so that means it's okay, we can leave here. So this is our I0. Okay, well, I have already written, that's not necessary. So now we are pushing the Goto statement. Okay, upon this less than sign. So upon this less than sign, the second production rule will be activated. Okay, you can see the second production rule will be activated. So upon getting the less than sign, the dot will be jumped after the less than sign. Okay, it will be something look like this. Okay, because it is just parsing the less than sign. Okay, it is parsing this arrow so that the dot is just changing its place. Okay, so now we can see the dot is before the capital L. Okay, so whatever production rules that are starting from the capital L, we need to write. So we can see that the two production rules are basically starting from capital L. So that is this one and this one. Okay, now we can see again the dot is before this capital S. Okay, the dot is before this capital S. So all the production rules that are starting from capital S, we also need to write them. So those are like S tends to dot L as well as S tends to dot ID. Okay, so these are all. Okay, we have written, we have taken care of all the possible options. So how many production rules are there? One, I mean how many items? They are saying that how many items are there in the Goto statement. So we can see 1, 2, 3, 4, 5. So overall 5 items are there in the Goto statement itself. Okay. So it means that we have 5 items in the Goto statement of I0 and less than sign. So that's fine. Now moving forward to the next question itself, it is saying, so it is a question from the syntax directed translation, and this question was also arrived in GATE 2019. Okay, so it is doing nothing but it is checking that consider the following grammar and the semantic actions. So support actions to support the inherited type declaration attributes. Okay, all the options should be inherited. Now there will be x1, x2 up to x6 will be the placeholder for the non-terminal DTL or L1 in the following table. Okay, so here we can get only up to we can see x4. Okay, x1, x2, x3 and x4 we can get these 4 in the semantic rules itself. And obviously x5 and x3 is also there. Okay, sorry, I have not noticed. x5 and x6 is also there. So fine, no problem. So firstly, let's talk with the x1 and x2. Okay, so that means the first production rule. So as it was discussed that it is using the inherited type declaration attribute. Okay, inherited type declaration attribute means inherited means the child can take the attribute from parent and the siblings. Okay, the child can take the attribute from the parent or the siblings. So basically this D tends to TL. The semantic action, if you say, so semantic rule will be something like L dot type, okay, will be equal to T dot type. It means what? It means that this L or T, okay, L or T are using 1. I mean this type of the L, type of the variable L is taking the type of the variable T. Okay, so it means that x1 should be L and x2 should be T. Okay, and now x3 x4, okay, x3 and x4, it is doing what? L and L1. So basically it will be like, what is the production rule? That is L tends to L1 comma ID. And what should be the semantic action? The semantic action should be L1 dot type is equal to L dot type. Okay, L1 dot type should be equal to L dot type. Okay, that should be the semantic action itself. So it means that if you compare with our given, given semantic rule, so there if you compare, so the x3 will be L1 and x4 will be L. Okay, because both of them are basically inherited. Okay, so as these are inherited, so the child will take the attributes from the parent itself. Okay, hence that is why L1 is at the left side, because L1 is the child. Okay, it is taking the attribute from the parent itself. Okay, and the same goes for our starting case also. So there L was taking attribute from T itself. Okay, so that is it was taking from the left sibling. So anyway, if we consider these two production rules, okay, if we consider this two production rule and if we change the semantic rule with our updated version, then we can get the x1, x2, x3 and x4. So that is L, T, L1 and L. So what is the correct option? L, T, L1 and L. So the correct option is option A. Okay, option A will be the correct option, that is L, T, L1 and L. So I hope that this question is also clear to you. Okay, if you have any doubt, please put it in the comment section so that we can understand your point of view. Okay, so I don't see any comments till now. Okay, if you have any queries, please let us know. We'll get back to you with the correct answer. Okay, so thank you for joining. Happy learning.